A very good morning to all. I welcome you all to this video session. In today's session, we are going to discuss on the topic Werner's coordination theory. In this video, before enter into this Werner's theory, we have to learn how the compounds are classified. I mean the types of compounds, oxidation number, types of bonding, basics in coordination chemistry, and then finally the Werner's theory. Yeah. So what is that? Types of chemical compounds. Compounds are actually classified as acids, bases, and salt. As we all know what are acids, many theories are there, including the Arrhenius theory. The acid is a substance which gives out H plus ion. Similarly, base is a substance which gives out OH minus ion. All we know. And similarly, salt is a substance which is actually produced by the combination of acid and a base. And when you come to the properties and nature of bonding in acids, base, and salt is concerned, actually there are two theories have been proposed at the time. One is what ionic bonding, another one is covalent bonding. As we all know, covalent bonding is actually formed by the mutual sharing of electrons. And when you come to the ionic bonding is actually formed between the elements by the complete transfer of electron, thereby the ions are produced and the electrostatic force of attraction hold the two atoms together. This is the nature how the elements are held in a molecule. And when you come to the covalent bond, we know it is because of mutual sharing of electron, I already said. And following that, oxidation number. It is actually playing very important role in understanding the chemical properties of any element. And what is that oxidation number is? It is actually an apparent charge possessed by an element during the course of chemical reaction. Okay, how to calculate oxidation number of an element? For that, some of the basic rules that we need to know. What are those basic rules? One is the sum of oxidation number of elements present in a compound is 0. That is the first point. And the second point is when you come to the hydrogen, which used to possess +1 as an oxidation number, but there is an exception, except in metal hydrides. Similarly, oxygen always possesses -2 oxidation state, except in peroxy compounds. And same way, when you come to the halogens, they always possess -1 charge, except in interhalogen compounds. And similarly, when you come to the first group element, like lithium, sodium, potassium, they used to possess always +1 charge. Same way, when you come to the second group element, they used to possess +2 charge. These are all some of the basics what we need to know to calculate oxidation number of any element present in a compound. Okay, fine. Now let us move on to that next point. Salt. Salt, we know that it is actually produced by the combination of acid and base that we know. And when you come to the salt, there is a cation and an anion is present, and the salt is produced or the elements are attached by electrostatic force of attraction, we know. And another important point that we need to know about the salt is when the salt is put into water, it used to provide all the constituent ions present in that compound. For example, when you come to sodium chloride, which used to furnish Na plus and Cl minus ions. Similarly, potassium chloride furnished K plus and Cl minus ions, as it is shown in the reaction here given. And similarly, when you come to ferrous sulfate, it ionizes into Fe2 plus and SO4 2 minus. And similarly, when you come to ammonium sulfate, which used to provide 2 NH4 plus ion and SO4 2 minus ion. What for we are learning this? Because we need to understand what is meant by the salt, simple salt. The next to that, we are going to learn about double salt. What is the meaning of double salt? It is actually produced by the combination of two simple salts. For example, When ferrous sulfate in combination with ammonium sulfate able to produce ferrous ammonium sulfate, generally known as. And this compound, when added to water, which is to provide all the cations or anions present in it. See to that the ferrous sulfate and ammonium sulfate upon ionization will give you Fe2 plus ion, NH4 plus ion, and SO4 2 minus ion. Similarly, when we come to the next salt, potassium sulfate and aluminum sulfate combination, potash alum, that all of this we know which used to actually make the sedimentation of the clay-like particle present in water, and which upon ionization, I mean added to water, able to provide all the constituent ions present in it like K plus, Al3 plus, and SO4 2 minus. Now, in 1860, what happened? Some typical compounds are prepared by some scientists. What is that? By means of combining copal chloride with ammonia. See, there are 4 compounds are listed here. All are having the formula like combination of copal chloride and ammonia. But in compound 1, there are 6 ammonium molecules are present. In compound 2, 5 is present, and compound 3, 4 is present, and compound 4, 3 is present. So like this is what actually the typical compounds have been prepared in the year 1860. But we were having that time only 2 theories about to explain the nature of bonding present in a molecule. They are covalent bonding and ionic bonding, that we know. But these are the compounds cannot be able to be explained with the help of those 2 theories. So that Werner, he tried himself to explain what would be the possible nature of bonding existing in that molecule. So that is called as Werner's coordination theory. And what is actually the method he adopted to put forward his theory? That is very, very important. He has given us the structure. First, we will let us look at the structure, and then we will go to the theory and the important point on the theory. See, first you look at the compound 1, which used to get ionized and give you what a complex cation, which is having a 3 plus charge along with 3 Cl minus out. And similarly, in compound 2, there are 3 chlorine atoms are present. It is visually we can see, but when they are getting ionized, you can see that it gives out only 2 Cl minus ion. What about the third chlorine, which is, of course, we know all the halogens used to possess minus charge, but here that chlorine unable to come out as a free ion. Why? Because it is present inside the square bracket. That square bracket is called as coordination sphere, which is called as coordination sphere. Okay, fine. Similarly, when you come to the third compound, only 1 Cl minus ion is coming out, and the fourth compound, no Cl minus ions comes out. Even then, it contains 3 chlorine atoms. So now, Werner have taken the idea of first, how come these structures have been given by the Werner? It's all because of the method what he has adopted. The one is conductivity measurement. He has made the conductivity measurement of those compounds, and he found that the compound 1, which was furnishing more ions, whose conductivity is what more. So on that basis, he identified that all the 3 chlorine ions are coming out, which is present outside the square bracket. And similarly, in compound 2, only 2 Cl minus ions are there, which are present outside the square bracket. So from the number of chlorine ions and corresponding conductivity value, we found those chlorine ions are not present inside the square bracket or the coordination sphere. They are present outside the coordination sphere. Similarly, when we come to the fourth compound, it was not getting any sort of conductivity. What does it mean there? Still it is containing chlorine. The chlorine atoms are not present outside the coordination sphere. They are present inside the coordination sphere. That's why they are unable to come out as chlorine ions. Okay, then second important test what he has adopted now, that is a simple test, that is reaction with silver nitrate. We know well that silver, when reacts with chlorine, will give you silver chloride precipitate. Now every individual compound has been treated with silver nitrate, and he found that the compound 1, which is shown here, having 6 ammonia and 3 chlorine atoms, all the 3 chlorine atoms comes out as silver chloride. In the compound 2, only 2 silver chloride is produced, and in compound 3, 1 silver chloride is produced. So thus, from the amount of silver chloride produced from every compound, what he has suggested previously with the help of the conductivity measurement, and he has I mean, he has got the additional, I mean, what to say, confirmation about the structure what he has proposed. Now let's come to the Werner's theory. On the basis of those tests, what he has conducted, he has proposed a theory. What is the theory? No, that is actually we used to say the oxidation number or valency, no, initially for every element, like first group elements possessing +1, plus the second group element possessing say +2, like that we used to say no. That way, metal ions not only possessing only one valency, and similarly they also possessing one more valency, that is called as actually secondary valence. So each and every metal ion used to possess two types of valencies. One is primary valency, other one is secondary valency. And now these primary valencies are always satisfied by anions. Like in normal sodium chloride, how Na plus is linked with Cl minus, same way all the primary valencies are satisfied by anions only. But when we come to the secondary valency, he said that, for example, if you want to understand the secondary valency, we need to go back to the slides where we are having that coordination sphere, right? So therefrom we can able to understand the secondary valencies can be satisfied not only by the anion, even by the neutral molecules also we can able to satisfy. So this is what the basis of Werner's coordination theory. He said there are two valencies possessed by every element. One is called primary valency, which is also called as oxidation number, and second one is secondary valency. Now the secondary valency is what given with some name. What is that name is coordination number. Coordination number. And then when you look at the structure previously given in the slide, so the compounds are proposed in such a way that the structure is proposed in such a way that some of the elements present inside the coordination sphere. So that is actually the coordination sphere which constitute both metal ion and some of the elements, and here ammonia as well as chlorine ions that we have seen there. So those are all called as ligands. So metal ion in combination with ligands first produce the coordination sphere, and the primary valency of that metal ion will be satisfied by the anion which is present outside the coordination sphere. So this is the way how Werner able to explain the nature of bonding in that compound. And now these anions as well as the neutral molecule, how come they are able to produce the bond? It is neither covalent bond nor ionic bond. So then what type of bond is present, or how the atoms are linked together then? For that he said the central metal ion is having or possessing vacant d orbitals. In these vacant d orbital, whatever the number of, we know that to produce any bond we need two electrons. So those two electrons when given by only one atom, a new type of bond is got formed, that is called as coordinated covalent bond. So Werner about to say that this is actually the coordinated covalent bond is produced between the ligand and the central metal ion. Okay, so this is what how Werner assumed, and thereby he was able to predict the structure, which we can see in the next slide. You can see there, here in the slide we can see that there are three chlorine atoms are connected through the dotted line. It means those are the three chlorine atoms are actually satisfying the primary valency of the central metal ion, whereas rest all the ammonium are linked to the central metal atom. No, it is actually satisfying the secondary valency. Okay, now in a nutshell, what we have discussed in our slide is that the nature and types of bonding in the compounds we learned, and meaning of oxidation number we learned, and valency, what is the meaning of valency, and what is the meaning of coordinated covalent bond, and what is the meaning of primary and secondary valency of the central metal atom. Okay, right. Now, thank you. Thank you for listening to the video.